Okay, guys, let's practice some naming of alkanes with substituents. So hopefully you've had a chance to look at this slide and do these on your own and try them on your own and check your work and go through them with me. If you haven't had a chance, go ahead and pause the video now and go ahead and play it when you are ready. So looking at this first molecule here, we need to figure out our longest carbon chain. So I'm going to start at this carbon down here, number 1, 2, 3, 4, 5. So it looks like there's no other way to make longer carbon chains. So I'm going to stick with pentane as my base. Okay, and then let's circle our substituents. We have one group here, one group here, looking great. Check our numbering. So let's look, we have a substituent at 2. If we flipped that around, our substituent would be at 4. So this looks good to me. Has the lowest numbering that we can possibly have. Okay, so now let's write out what our substituents are. We have at the 2 position a chloro, and then we have at the 3 position a methyl. So if we're comparing for our ABC, we compare chloro to methyl. Chloro comes before methyl, so the total name will be 2-chloro, 3-methyl pentane. Let's arrange this nicer. Ooh. I wrote this really big, guys. I don't know how to get to this. You know what, let's just rewrite it real quick. 2-chloro, 3-methyl pentane. That will teach me to write smaller. There we go. Okay, next problem. First step again, find our longest carbon chain. So I'm going to start, I always just like starting in the same spot. Start right here, number 1, 2, 3, 4, 5. If I keep going down, it's obvious that I'll only have 6, but there's more carbons going up. So let's keep going up, 6, 7, and 8. Let's circle our substituents. We have one here, one here. So this looks like we're going to have a substituent at number 6 and number 5, or 5 is the first one. However, with 8 carbons long, we could make that smaller. We can make it 3 and 4. So I'm going to go ahead and erase my numbering and switch those out. 1, 2, 3, 4, 5, 6, 7, 8 carbons long. Okay, so we have 8 carbons. That means it's octane. And then we need to identify our substituents. We have 2 methyl groups. So this is going to be dimethyl. And then we need to say where they are. 3, 4 dimethyl octane. And that's the answer. We'll put it in a line. Great. Okay, last practice one for this slide. I always start in the same spot, so let's start here. Number 1, 2, 3, 4. Going to the right, I'll have 5, 6, 7, but going down, I'll have 5, 6, 7, 8. So we'll go that way, 5, 6, 7, 8. Looks good. It looks like we're gonna have octane again. Go ahead and write that. Okay, and so let's identify our substituents. We have one here, a nice long one here, and then 2 off of number 1. So let's list these out and then put them in order. We have at carbon 1, 1, 1 difluoro, because we have 2 fluoros. We also have 4, I'm going to put down here, 4 propyl, and we have 5 methyl. So to put these in ABC order, remember that the di or tri does not count in our assessment of our ABC order. So we have F, P, and M. So it looks like fluoro comes first in the alphabet, I hope, if I did my alphabet correctly. So we have 1,1-difluoro. Next is 5-methyl. M comes before P. I don't think this will all fit on one line, guys. But that's okay, we can do 2 lines. And then for propyl, we're gonna add our dash here. So the final answer for this one is 1,1-difluoro, 5-methyl, 4-propyl octane. It's a mouthful. Okay, drawing structures from the name. So now we're going to go opposite for a little bit. The first thing that we're going to do, if we are given our name of our molecule and we need to draw the structure, is we're going to draw the main alkane chain that we're given. Then we're going to number the chain and place substituents on the correct carbons. And then lastly, we're going to add all of the correct number of hydrogens that we need. This is only if necessary, though, because in our skeletal drawings, it's implied, so we don't necessarily have to do that. So there's really only 2 steps to do this. So let's try our first one here. We have 2-chloro, 3-methyl octane. Octane is our main chain, so I'm going to draw an octane chain. 1, 2, 3, 4, 5, 6, 7, 8. I always like to double check myself and number. Okay, cool. We have 8 carbons here. And then we add in our substituents. So we need a 2-chloro group. So at the 2 position, I'm going to put a chloro. And at the 3 position, I need a methyl group. That's it. That's all we have to do. It's a lot easier to draw it this way, huh? Okay, let's do one more example and then we'll do some practice problems. So now we have 3-cyclohexyl-nonane. This one's a little tricky because it's not a substituent I gave you. First off, we're going to draw nonane. That is 9 carbons. 2, 3, 4, 5, 6, 7, 8. Don't you love how straight my lines are on this iPad? Okay, let's number our carbons. 1, 2, 3, 4, 5, 6, 7, 8. I even missed one. And 9. See, this is why we number. Okay, and then next, we need to put in our substituent. So a YL group, or YL means that it's a substituent. So, and when we see 3-cyclohexyl, that means that we're going to have at the 3 position a bond and then whatever we have in that before the YL, cyclohex. So I'm going to draw a cyclohexane group. This means it's a cyclohexyl substituent. And there's the answer. Okay, so we have some practice problems here. Go ahead and take a moment, pause the video and do them on your own, and then I'll do them with you. Okay, so let's just go ahead and do them. Hopefully you had a chance to pause the video. This first one, we have heptane. That means 7 carbons. 2, 3, 4, 5, 6, 7. And then continuing, we need to add in our substituents. So at the 3 position, we have a chloro group. Just like that. Let's move over to the right now. We have 2,3-dimethylhexane. Hexane is our main carbon chain. Let's draw that first. 2, 3, 4, 5, 6. Number it. 1, 2, 3, 4, 5, 6. And then we have 2,3-dimethyl. So at the 2 position, we have a methyl group, and the 3 position, we have a methyl group. Pay attention to this, and that doesn't mean that there's 2 methyl groups at each of those positions. So the 2 methyl groups you're looking at, one's at 2, one's at 3. And our last one we have heptane is our main chain name. So let's do 7 carbons long. 2, 3, 4, 5, 6, 7. Hopefully. 1, 2, 3, 4, 5, 6, 7. Beautiful. And then let's add our substituents in. We have 2,3-dibromo. 2-bromo, 3-bromo, and then 1,1,1-trichloroheptane. So 3 bonds off of number 1, and all of those are chloro groups. Okay, so let's just double check. 2,3-dibromo. Okay, check. We have 2 bromines. 1,1,1-trichloro. 1, 2, 3. Beautiful. And we have 7 carbons long. Got it right there. Okay, so this is where we're going to be done talking about naming our substituted alkenes at this point, and I'll see you guys in the next video.